sorry about so. So first of all, we wanted to start with a bit of evolution from 1G to 5G. As you all know, 5G is the fifth generation of some global wireless standards that we've been seeing in the past three decades now. 1G, 2G, 3G, and 4G, but it's the one that compared to all the previous technologies is expected to have more opportunities, especially for businesses, so for the emergence of new business models, as we've been seeing also during these morning sessions, and as we will be seeing in our use cases, the creation of new innovative services, and also transformation of the way that some sectors currently work, as we will also see in the use cases that our experts will present later on. If we look back in time, we see that we started from a very basic technology, in this case, 1G in the 1980s. Here, we could do voice calls from not fixed locations, but these were non-secure voice calls that were accessible to other people sometimes. We went from this to 2G in the 90s, which included international roaming and improved the quality of these calls and also the security of these calls, and then introduced as well text messaging through the SMS that most of us used back in the day before there was WhatsApp and other applications. Then we moved in the 2000s to 3G. Here the technology was built on 2G, but it was delivering higher data rates, and it was also the first technology that paved the way for smartphones as we use them today. In 2010, we moved to 4G, sorry, that had significantly higher mobile data speed and network coverage, but it was unable to deal with the unexpected need for more capacity, which is what 5G nowadays is expected to cover. It has much higher data speed. It also has much connectivity, a range of mobility and reliability, as we will see now in the benefits, and it allows for the development of communication applications that were not possible before. But this is a technology that is expected for a while to coexist with the previous technologies until the devices that are supporting 5G are significantly used. If we go to the next slide, what are the 6 main advantages that we see that 5G has in comparison to 4G? First of all is enhanced coverage. As we know, it provides consistent coverage in remote areas and later as well. Lower latency, as now the device's response the response time has gone from 10 milliseconds to 1 millisecond. From 1 millisecond to 10 milliseconds, which is the opposite, which is critical for real-time data exchange, and this is going to be seen as well in the use cases that we will see later on. Higher mobility, as 5G supports availability for users in very high mobility contexts, and this is especially relevant if we talk about the high-speed trains. Higher user data rates, as it ensures a peak data rate that is better compared to 4G, of course. Lower energy consumption, which is meant to compensate for the power consumption that is caused by higher data usage. And enhanced connection density, as it supports up to 1 million connected devices per kilometer, kilometer square, which is a lot compared to what we had before, which is 2,000 connected devices. So as we see, it has widely improved what we had, and it has also provided several opportunities that now Ioannis will present in the next slides.
Thank you very much. Just to highlight that apart from the better performance that 5G will provide, it is not just an evolution of the previous generation, but also evolution stemming from the fact that 5G can provide a new business model, mainly due to slicing technology, which gives the ability to share the physical network, to split the physical network into several virtual networks with different characteristics, which is very important both for end users or the consumers or industrial users. Now, regarding the opportunities, we have separated the opportunities for consumers and the opportunities for businesses and industries. Regarding the main opportunities for consumers, these are also the benefits of 5G regarding consumer applications, stemming from the better performance of 5G. First of all, we have enhanced video, 4K, 8K, and other formats like 360-degree videos. We have also live sports streaming with the ability to provide different angles of the same event. Music and gaming applications, both mobile and cloud. We should also highlight here that online gaming is assumed as one of the most promising use case for 5G. Of course, augmented reality and virtual reality, which I guess that this will be further analyzed by our experts, Panagiotis and Luca, in the presentations that are following. IoT services, of course, in-car entertainment and connectivity, which is very useful, especially when automated cars will operate, and digital advertising and personalized services, which is very important for consumers. These were from a study carried out by Ericsson, and on the right hand, we have almost the same opportunities and benefits, but we have a split by the adopters of the services. For example, better services in locations with poor reception is among the top services and benefits. And with an equal importance between all users, early adopters, early majority, laggards, etc. Next slide, please. Although governments are pushing for the deployment of 5G networks, operators are reluctant to invest because they cannot see a killer application. Moreover, consumers are not willing to pay more for only higher speeds. On the other hand, industries are willing to pay more, especially in case 5G will solve some of their problems and will unlock new business models. According to a study conducted by Ericsson, we can see that consumer-related revenues are expected to remain flat with a small, let's say, growth with an annual growth of 0.75%. However, on the other hand, industrial revenues are expected to have a compound annual growth rate of about 12%. So we can understand that the opportunities for industries and industrial cases are expected to be more promising in the near future. So operators, service providers, as well as industries should, let's say, redefine their strategies and prioritize their target areas and goals. The next slide. Regarding the opportunities mainly in businesses and industries. As mentioned before, we have new business models exploiting the slicing technology. With new business models, we can exploit the vast amount of data availability through countless connected devices such as sensors, cars, IoT devices, etc. Private networks will play a significant specialized in business. Then the ability to transfer and visualize data in real time will provide operations personnel or customers with great insights and the ability to read and react effectively. And the last one, the seamless interconnection of numerous devices will open a new era of agile automation without having customization, flexibility, or quality. So all these benefits are contributing to the digital transformation of industries, either to their, let's say, production lines or products or sales provisions or ongoing support processes. I don't know if I have more slides.
Yes.
Yes. Some figures about the opportunities. Again, a study by KPMG showed that an estimated of 4.3 trillion US dollars in value is waiting to be unlocked across the major industry verticals. We can see that in the near future, the most promising, let's say, sectors are manufacturing and media and entertainment. And later, we are expecting some opportunities and some value in other sectors like finance, professional services, and retail services. In the right hand, see the share of global 5G maybe business-to-business opportunity for service providers. The most promising sectors are healthcare, agriculture, and manufacturing, as also mentioned in the other study. I think more or less these are the opportunities for both the consumers and the industries. And we should have in mind that 5G has also a bidirectional relationship with technologies. 5G can be an enabler to other technologies like artificial intelligence, blockchain, augmented reality, and virtual reality due to the better performance characteristics, fast connections with low latency. However, 5G can also be benefited from these technologies in order to provide advanced use cases, while other technologies are mandatory for the achievement of these, let's say, performance characteristics, like new business models like slicing, as mentioned before, or the edge computing, which provides the low latency KPI. I think this was my last slide. Thank you very much. And now we would like to give the floor to our two experts. The first one is Luca Mignaroli from RAI, from Radio Television in Italy. He's an engineer and researcher in RAI and a good friend. And also Panagiotis Arianidis, who is a professor at the University of Western Macedonia in Greece. Tourism-related topics, while Panagiotis will present smart agriculture and 5G and agri. Thank you very much. The floor is yours.
Thank you. Good afternoon, everybody. Many thanks for the. Okay, do you hear me? Do you hear me? Okay, good afternoon. Thank you very much for this invitation. In my short presentation, I give you an overview on use cases done in the 5G Tours project. Next slide, please. Okay, let me very briefly introduce the project. The project 5G Tours is an European funded project. The consortium is quite large. We are 28 partners from 6 countries. The coordinator of the project is Ericsson Italy. Next slide, please. Let me introduce the goal of our project. The project aims to improve the life of citizens using new technologies. With the introduction of a number of use cases, empowering vertical industries. This project is based on field trials, so we can touch with the hands something that is possible to do with 5G technologies. We are a number of multiple verticals that are working in 3 different cities in Europe. Turin is the touristic city. In this case, the vertical involved are museums, foundation, and the broadcaster and the media company. We have also Rennes, that is the safe city, in which the main vertical is the hospital of Rennes, and the mobility city, that is Athens, in which the main vertical is the airport of Athens. Next slide, please. Okay, welcome in Torino. Torino is the touristic city of the project, and we try to demonstrate 5G benefits to improve tourist and the vision of vertical actors in this city. We are different stakeholders in the sense that we study in the ecosystem of a smart city, which can be the role of the foundation for museum, and also the broadcaster, and what could be the media company role inside the value chain of a touristic city. In Turin, we are working, let me say, in 3 different areas. The first one is about the enhanced museum experience, in which we have a number of use cases related to AR and VR, and also something related robotics. Robotics has assistant to the visit to the museum, and also with telepresence activity and use cases. Then we have a broadcasting related part that involve the media company, like RAI, of course, in two different aspects that are from the production of content and for the distribution of content. Next slide, please. Here you can see the two main places in which the trial are placed. The first one is Palazzo Madama, that is located in the very heart of Turin. Palazzo Madama is a UNESCO World Heritage Site, and it was the first Senate of the Kingdom of Italy. And now the palace hosts the Civic Museum of Ancient Art Collections. And the other main place in which we have the trial is the GAM. The GAM is the Civil Gallery of Modern Art, and in which there is a large collection of over 50,000 works from the 18th century to today. Next, please. Okay, now I introduce the use cases that are related to augment the experience in the museum. Next slide. Okay. Before to introduce use cases, something about some lesson that learn during this activity that is about the content creation. We saw that a key aspect to introduce new services related to museum is the creation of very good content. As RAI, we perform a number of 3D scanning from artworks, from object. Here you can see an example of ceramic that we are captured in as 3D models, and also rooms inside Palazzo Madama to introduce this type of content inside the application that will be offered to the tourist. Another very important lesson learned is the storytelling, because people that are working in museum has to learn to change the storytelling with the this new type of technology, new type of content, and this imply that there will be also a new type of storytelling to show in the in a good way this type of content to the final user. Okay, the next slide. Here you can see some example of application related to the augmented reality part, in which the user with the smartphone inside the museum in this case Palazzo Madama, is able to interact with the ambient in which he is moving. So visitor can explore artworks and using beacons installed in the museum, and also using the visual recognition application. The user is also able to touch with hands some object, in this case ceramics, during the visit. And also here you can see also another part that is related to how can we help the visitors also after the visit to the museum, with the integration of the smart city features, like another museum that the visitor can see, or the way to go in this other museum, and so on. This is to improve the experience of the tourist. Another slide. Okay, another key aspect that we take into account in this use case for the tourism is the VR gamification. Two different VR applications are under development. One is in Palazzo Madama, and it allow the visitors to solve a puzzle with the artworks in a room of Palazzo Madama. Another one is located in GAM, in which we are installing a huge wall screen, in which there are an application that allow user using gesture to interact with some shape that are created from the Nicola de Maria paintings. Here you can see some example of this type of application. Okay, now introduce the robotics part of the project. Okay, here you can see our application that is called Exclusive Exhibition for All. In this case, we use a robot that allow people to have a remote visit to the basement of Palazzo Madama. Typically, this is an area that is not accessible to the public. And we are installing in the upstairs a totem in which the user can move the robot that is, let me say, 5G controlled robot to visit this basement of Palazzo Madama. And of course, we are also introducing the surveillance use case, using more or less the same techniques. The next one. Okay, This is the R1 robot. That is an humanoid robot from IIT. It is the Istituto Italiano di Tecnologia in Geneva. This robot is used to the use case robot assisted museum guide. Is an autonomous robot that is able to carry out people through the museum, speaking with visitors and showing the collection. The next slide, please. Here you can see one of the floor of the GAM museum. This is the map. The R1 robot is able to show 6 different artworks in this floor. Okay. Now the 5G for media delivery in the project. Okay, I introduce very briefly this part. This part is about the broadcaster, and we are we are working on the 5G broadcasting part. For the broadcasting part, we are involved as RAI using a particular 5G technology that are not one-to-one transmitting mode, but is one-to-many using the high tower broadcaster infrastructure. The next one, please. This technology is complementary by what we can do with the mobile network operator. Could be cost effective in case of a multi-user content in which many users has to be use the same context, the same content. Okay, the next. During our trial, we will be able to transmit from a transmitter that is on the hill of Torino a 5G broadcast signal in the same context of the next use case that is the itinerant orchestra. The itinerant orchestra event will be broadcasting in all the city, Turin city, using this type of technology. The next one. Okay, here the itinerant orchestra. The itinerant orchestra, the goal is to join together technology, the touristic part of the city, the smart city, and also the remote production television world together. We aim in the itinerant orchestra to organize a concert in which some musicians are located in a concert hall, and other musicians are itinerant. They are walking in the streets. The target of the experiment is that the public inside the concert hall can see in real time, see all musician sounds play together, and see the remote musician has virtual presence together with the local orchestra. The next slide. As I said, this is not only a technical challenge, but also an artistic challenge. The composer and orchestra director Andrea Molino joined us for this experiment, writing a specific composition for this event. I can say that the event will be in November, the 9th of November. We are working a lot for this activity. And as said by Andrea Molino, this type of use case and this type of technology can revolutionize in some way the live event inside smart cities. Speaking about event based on marching bands in the city. Okay, the next slide. Here you can see some picture that are coming from our first trial, in which for the first time we was able to have 4 musicians that was playing together in this with this type of technologies. Of course, to have this type of use case working, we need an ubiquitous access to the network. Let me say, we use the commercial network of Teams for the outside coverage for this activity, and also a specific installation of an ad hoc 5G coverage also inside the museum, done by Ericsson. So we need a low and constant end-to-end bitrate, of course, reliable connection, and a very high throughput, especially for the uplink of the cellular network. We need, for example, we need for our event to have 4 different cameras connected with the control room. Each cameras need to have 20 megabit per second in uplink. So we need a total capacity for the uplink that is 80 megabits per second. That is very high for the network, and this feature is not possible with the traditional 4G technology. The next slide, please. Okay, very quickly, we have a lot of signal to be managed for this event, because there is not only the video audio-video signal coming from cameras, but there's at least two different intercom system, one for cameraman, but one that is very important from the music director to the itinerant musician for the synchronization, and all signal are then remixed in the control room in order to present synchronized signal to the public inside the concert hall. Here you can see also our plan with all a part of musician that during the event from outside of the building go inside and then join the main orchestra. The next slide. Okay, this is some pictures for our first trial in December 2020. In 1 month, we have the final event, so stay tuned. And I think that this is my last slide. I don't know if I have, thank you very much, if I have time to show a short video about the first time that musician was able to sound together or not.
Lucas, since we're a bit delayed now, what we suggest is first let's go to the questions, because we already have one question from the audience. And maybe at the end, is it a very short video? How many minutes?
3 minutes video.
Okay, so it afterwards, after answering this question from the audience, maybe, in case there's another one. But
no problem.
This question we got is from Mariangeli David, and the question is related to the tourism experiment. What is your suggestion in addressing devices from tourists not being 5G ready?
But the lesson learned is that the main things are content, but content that are in very high quality. Let me speak about a personal experience in which we was able to capture object rooms in the museum with a lot of particular aspect of all feature of object and spaces, and what in the first time, in the first part of the project, their request was to cut this type of quality. I think that using 5G, we need to not cut, not reduce quality. We have to try to use the technology with something like full quality. I don't know if I have answered the question.
Okay, we have another one yet. It's from Mario Cabellos, and the question is, in general, are users, visitors satisfied with the 5G-based services? how is the positive impact of these new services measured in the project? How are you measuring this, the progress or the success of this?
Let me say that in the project, we are in planning to have the trial with visitors. So let me say that the planning is to have visitors and groups of visitors involved as real user in 2 months from now. So we hope to have this type of answer in few months, because now we are our effort is in arranging the final trials, and the first trials of the different use case will be the itinerant orchestra in the beginning of November, and then in January to February and March we will have the other 3 use cases related to ER, VR, and robotics. So we need to wait some months to have the real feedback from real visitors.
And last question, because as we were saying, we are a bit tight on time. It's again from Maria, and the question is, there were also mentioned in the earlier slide that the number of devices connected will not be an issue. Did I hear that correctly? If yes, how is that possible without choking the bandwidth?
Hey, yes, this is an open question. As vertical, we can say that we need some performance for the network, and this activity is more related to mobile network operators that has to be ready to give to verticals and final users all features that are on the table of the 5G.
Thank you, Lucas. We're a bit tight on time, and since we also have another use case now, maybe let's see if we can share it later, but we would give the word now to Panagiotis so that he can present his use case. We're very sorry, Luca, and thank you again for this presentation.
You're welcome. Thank you very much.
Thank you. So maybe Ioannis, you want to present Panagiotis? Or?
Yes, Panagiotis Tsariganidis is a professor at the University of Western Macedonia in Greece. He is very active in 5G and IoT, and he will present 5G along with smart agriculture case. Panagiotis.
Okay, we're having an issue with the presentation. Let me try to share my screen for this because it doesn't move. Can again? Yeah, I'll try. Thankfully, we have a help desk that can help us with this issue. Okay, otherwise let me try and do it. Can you now see it? Can you check the chat for a minute to see if, okay. So, Panagiotis, when you want, you can start. When you want, you can start.
Hello. Sorry for the delay. It was a blackout here in the region, so it was just recovered. So, okay. All right. So thank you for the invitation. I'll be very glad to join to the today's event and to talk about the 5G on smart agriculture. I'm Panos Aragianidis. I'm coming from Greece. I'm director of Ithaca Lab in University of Western Macedonia, and dealing with smart agriculture and smart farming is of high priority here in our lab. So I would be very glad to give you some insights about our experience and a project, an H2020 project we are coordinating called Terminate, where we have a use case in smart animal monitoring. So next slide, please. Okay, so the playground of 5G is well known. Just to say here that smart agriculture is one of the main applications, of the main pillars of the 5G based on the latest regulations. And what is the main advantage that 5G offers to smart agriculture? The MMTC, where multiple current working connections realized in the same region, covering a lot of sensors, gateways, aggregators that will be of high use for monitoring and providing decision making in farms and in livestock regions. Next slide, please. So the advancement and the cooperation between 5G and IoT is also well known. What is most important for smart agriculture is that the number of IoT devices is expected to be scaled up, largely, highly scaled up. So 22 billion IoT devices are expected by 2025. And smart agriculture is of high interest here since, as Johannes mentioned before, there is a lot of potential and new next generation IoT devices are expected to open the market to include more end users in the ecosystem and also to increase the benefit and the market revenues here in smart agriculture. Next slide, please. So it's being developed and evolved in some large levels lately. So precision farming allow us to digitalize a very traditional, let's say, topic of production and domain of production by upgrading their ways of monitoring, the ways of getting profits, the ways of opening the market, providing new brands, and also to advance all the ecosystem to a cyber physical system where new robotics, new devices, new vehicles, and of course drones are coming into play to advance and offer many benefits to the end user. Next slide, please. So how 5G could contribute to smart agriculture? First, to open up a new market and new devices. Second, to provide new data collection, new data gathering, and new intelligence to the end user for optimizing the decisions that could be made. Third, to also to foster AI, to provide by using drones, by using autonomous vehicles, and also to allow better decisions, reducing the cost, and also to reduce the chemicals that is used, together with better irrigation, better water consumption, that also opens a way, pave the way to improve or to foster or to mitigate the climate mitigations, the climate implications to farmers and producers. So no, there's no only technical contribution here, but also contribution to climate change, contribution to green technologies, and also an open window for a better and greener life coming from the production and the food production. Next slide, please. Here you can see some basics on the smart agriculture, like aggregators, cameras, multi-mode cameras and night vision cameras, sensors, gateways, and chargers. All these things could open a new network ecosystem in the infrastructure. And of course, what is needed here is better connections, connectivity and coverage, in order to include more farms, more livestock, more areas, maybe some rural areas and some coastal areas, by including farms like aquaculture farms that are not currently supported by high level and high accurate connectivity, high accuracy connectivity. Next slide. Specific benefits coming from 5G. More sensors, and more sensors means more data. More data means more accurate decisions. So better forecasting, better predictions for the end user. Also 5G powered drones, and another option here is to use multi-drones or of drones to have a better view and sights of the farm and beyond. Scanners and in order to also to have a better monitor and better view without human intervention and human interaction with all these devices. And all the opportunities are getting better in order to also increase the income, better monitoring the farm, and also to to provide better wellness and better quality indices of the final products like the meat and the milk. Next slide, please. All right, so by combining machine learning and computer vision with 5G connectivity, we can have some new research topics here, like the soil management, the water management, the yield estimation, the quality of cultivation, also better animal monitoring. But I will stay a bit on the disease detection, since we have a lot of projects here in Greece about anomaly detection, how machine learning could contribute to anomaly detection, earlier anomaly detection, by providing warning systems, and then to transmit and use all these data collected and all this knowledge to the cloud by using 5G or 4G and 5G connections if needed and if applicable. Next slide, please. So here we have a lot of process now to store and process all these information needed. All right, the latest trend dictates that this should be done in the edge. So we try to move the intelligence and the data process to the edge However, if we are going to do that, we need strong and high throughput connections to transmit and receive all these high level of high volume data. And also what is needed here is to connect better the new devices like robotics and drones to the cloud and to the end users. So we need high capacity, low latency, and stable connections, for example, between drone and base station, drone by drone, and also to the gateways installed in the farms, let's say, to the cloud. Next slide, please. Here you can see a very practical example of what is the output of the process. So here we have some cherry trees, and we try to apply machine learning to see if a tree is stressed and if a tree is dead and need to be replaced, or to take some countermeasures on that. In order to get this output, as you can see it now, we have to get many high quality photos by cameras and by drones in order to have accurate and concrete results on this kind of research. So, for example, for these photos, getting this output, we had to get and communicate more than 1,000 photos per tree, and also very large volume of data coming from the sensors. For this specification, we had 3 or 4 sensors per tree also. So the conclusion here is that we need a lot of data, and all these data are processed at the edge in some level, but also we need to support all of this process with high quality and high throughput connection coming from 4G and 5G also base stations. Next slide, please. Here you can see as well the process coming from a specific software on identifying disease symptoms. And the next step here is to have real-time detection. Since this kind of detection is not real-time, it's offline, it's working in offline mode. So if we can imagine a real-time environment where the farmer could see something in real time and accurate as well, here we need an AR/VR environment. And what we do in Terminate is to support this environment by some end devices like 3D glasses. So the farmer could see all of these very good results in order to take some countermeasures. But for this need, for covering this kind of need, the requirements say that we need 5G related or 5G requirements in the connection. So about Terminate, we're very happy to coordinate this ICT 56 project. We have no concrete results since we are running the first year of the project. However, this project, as you can see, the consortium as well, it's very promising, including many use cases. One of the 6 use cases supported has to do with farming and animal monitoring. So here we have American Farm School in Thessaloniki, Greece, where we have 2 farms with cows, mostly with cows, in order to monitor and to have many very, very useful applications on farming and real-time interaction with AR/VR environment coming with 3D glasses. So in the next slide, we could see all right, the 6 objectives of the project. Just to refer the 2 main things here. First, the intelligence to come back to the edge. So we transfer the intelligence coming to the edge, and we try to enhance all this machine learning and artificial intelligence running at the edge and the sensors at the gateways and within the glasses. And the second important thing is new market. So we try here to test and introduce a new kind of next generation IoT device like the 3D glasses, able to support all these output coming from the edge, and also some haptics in the remote surgery we have here, and also in the some testing in AR VR environment in critical infrastructure. Next slide, please. Here the use cases of Terminate will be presented. Next slide, please. All right, so six use cases total. Two of them has to do with the healthcare domain. One has to do with supply chain in milk production. We have this one in smart farming, and also we have another one in smart buildings and smart cities by providing sustainable and efficient lighting in buildings. So in the next slide, we can see some details about this use case in smart farming. So we have a lot of data coming from different sources, coming from monitoring crops, monitoring livestock, mixed farming systems, coming from by using drones or sensors or gateways. So we have to deal here with the many levels, the high levels of data, and also the heterogeneity of data. And we focus more on the animal-like features. We have some wearable collars, so we can measure, for example, the temperature of the animal. We use also animal identification, and all these kind of data are processed and are transmitted by using 4G or 5G connection here to the 3D glasses in order to enhance the visibility, the capabilities, and the decisions of the end user, where the end user here is the farmer and the producer. Next slide, please. So, for example, we try to advance this kind of 3D glasses coming from Augmented. Augmented is a partner of the consortium, and we are going to evaluate their capabilities in latency, throughput, and battery in order to see if all this combination of all these features are able to support the new generation of smart agriculture, 5G enabled smart agriculture. Next slide, please. Here you can see some examples of how all this smart animal monitoring could be applied. First, identification. Second, the realization of all this animal tracking in the glasses. Next, please. Also, smart glasses could automatically request could provide a view of the animals nearby, could also define digital fences or to identify which animals are suffered from some kind of illness or are featured as in pregnancy. And of course, the farmer and the producer should be able to consider all this environment in real time, and to take decisions also in real time without, heavy interaction. So by having these glasses, maybe some a mobile phone, all this ecosystem becomes more visible and friendly, and of course efficient to the decisions of the producer. And I have also two slides here about federated learning, since AI and machine learning are of high importance in 5G enabled applications. Here, where we apply federated learning in order to collect data coming from many sources, from many farms, for example, without exposing the data. So we use the data to train some global model without exchanging data, in order to have some decisions on, for example, the quality of the milk or some very specific features of the milk, some chemical indices, for example. And in the next approach, in the next slide, you can see also that federated learning. So next slide, please. Federated learning could also take and process data coming not only from different farms, but also from different domains in order to combine the trained model and to provide some decisions coming from many domains. For example, we have the supply chain of a milk production, a milk industry here called Mevgal. So we could acquire data coming from Mevgal and coming from the farms as well in order to get more accurate and optimized decisions here. All right, so I would like to thank you for your attention. I have to say that smart farming and precision agriculture is a bit underestimated still, but the market is opening. I think it has a great potential, and 5G could also open the way, pave the way for more for more next generation and market-oriented products. And the farmers and the end users and the producers could be of high value benefit from this new technology. Thank you for your attention, and I'll be very glad to answer your questions.
Thank you, Panos. This was a very interesting intervention indeed, and we have some questions. I know we are over time due to the technical problems we had at the beginning, so we apologize for this, but let's see if we can answer just some quick questions. First one from Justin Stevens is, what vendors are supplying the 5G technology Terminate for the farms?
Yeah, currently in the Terminate consortium, we have everis in Italy, so they are helping a lot for supporting all this 5G connectivity. But also we have, as a university, we have also some SDR and technology that could emulate all this, microcell and picocell in order to have some tests in the lab and in the field as well.
Okay, and thank you. And another question now from Mario Cabellos. From an investment perspective, does it make sense to think that this kind of solution also could be considered by small farm owners or even individuals with crops in a small piece of land?
That's a very good question. That's the main, the main rationale behind using all these technologies. Since, as Mario mentions here, if we're dealing with a small farmer here with no major investment capabilities, then we have a dilemma. So should he invest or not in such technologies? And this depends on the final revenue. Currently, for smart farmers, this investment is not so, let's say, attractive. And I fully understand the rationale behind this question. However, smart farming and precision agriculture should be treated not in individual mode, but it should be offered like a service. So, for example, here in Greece, in the region of Western Macedonia, we're in very close collaboration with some policymakers, like the region of Western Macedonia, to support the farmers and to provide all these kind of new services in a community level without charging individually each farmer. So there are many opportunities to do that. In any way, the cost, if we are going to consider as a massive deployment, is not so high for the final user, for the farmer. But I have to say that the local policymakers and the local communities should be collaborate, should be aware all of these technologies and to support them in order to reduce the cost for the final user. In such way, the market will be opened in very fast, and all these new devices will penetrate the market more quickly.
Okay, we have two more questions. One is from Daniel Hamadeh. I hope that I will say well the question because it's quite technical. So it says, are there any features and capabilities that are not possible to implement via LTE and only supported via 5G, knowing that most of the mission critical features are mature in LTE-A and not 5G before 12, 17 or beyond? I hope I said well all the elements of the question.
Yeah, that's a technical question. I cannot see any specific obstacle regarding the region of interest, this application of interest, the smart farming. For now, I can say that the requirements, especially on the connection and the throughput, are not so high. I mean, we can live with some older versions of LTE. That's enough for now. However, if we are going to to advance all this ecosystem by using AR/VR and by using also real-time video streaming or real-time video broadcasting or some kind of drone-to-drone communication, then the requirements are evolving, and we need some kind of guaranteed connection, throughput, and latency. But also, I can say that this kind of market is evolving slow, and it depends also on the region of interest. So if we are going to speak about some large farms, some large industries, and some community, some end user that could advance, and the potential revenue is high, then yes, there I can say that by using some kind of let's say closed or ad hoc 5G connection, licensed connection, and licensed way of market contract, then this is feasible. I'm not sure what is going to happen with the smart farmers or the farmers and the farms that are in rural areas. This is an open question. I'm not sure what happens with them. There's a need for a customized and up to the case business model to answer this.
Okay, and to finalize with this use case, more than a question, we have a comment or a reflection by Vincent Glasner, which says, one of the challenges besides the strictly technological XG is also an aspect of property and access or non-access to the raw and second level data and the potential impact for the farmers. I don't know what are your thoughts on these panels, and with this we will close this session.
Yeah. That's a good question as well. If I understand well, this goes to the privacy and the protection of the data. I can say that smart farming and precision agriculture is not of high priority regarding the data protection and the sensitivity of the data compared, for example, to some kind of healthcare application. However, this is something also that should be considered and treated well based on the current EU regulations on, for example, the AI and the gender and everything within the kind of data and the source of data, and that's why. And this is a good, let's say, you can say that this is a good recommendation from my side. When dealing with the data processing, we could choose technologies that that are designed, that are privacy preserving designed. So, for example, in Terminate, what we do is to apply federated learning. Federated learning is featured by something very major and something very important for us. It allows the data processing locally without exposing them and without, allowing the direct data exchanging. So we could work farm by farm without exposing the data. And at the current time, we train the global models in order to use them for interesting decisions that could benefit all the parts of all this training process. So by using federated learning, we solve this kind of data privacy in our case. But Vincent is right. We should always take care of the data and how these data are dealt, are managed by all the actors of this ecosystem.
Thank you very much, Panos, and thank you very much, Luca, as well, and all of you that have been attending and asking very interesting questions indeed. We're going to close the session now, but for those that were curious about the video that Luca was about to share, he's agreed to share it now. It's only 3 minutes, so we encourage you to stay. And thank you again on our side for attending this session, and have a nice evening. Thank you, Luca.
Okay, I'm sharing the content.
The itinerant orchestra experiment aims to allow musicians located in the main concert hall play together with some other musicians walking in the streets. This experiment is extremely challenging and requires very low and stable delays, an ultra-reliable capability, and a very large bandwidth capacity in order to reach a good final result. Starting from July 2020, the 5G Tours team performed test activities over the 5G network in laboratory. The first part was a functional test in order to verify behaviors of involved equipments. Then the test was performed with BEPAX to transmit over the 5G commercial network. For the experiment, the commercial 5G network is used for the outdoor coverage, while a specific indoor coverage was granted by an ad hoc deployment. In December 2020, the first trial took place in Palazzo Madama. The composer Andrea Molino wrote a specific music for this experiment in order to emphasize the use of new technologies in the music world.
you very much.
Thank you, Luca. Indeed, it was a really good video. Thank you for sharing it, and we are willing to see what happens in November with the
Yes. Stay tuned with the 5G Tours YouTube channel.
Okay.
There will be the full event there.
Okay. Thank you very much, Luca, and thank you, Panos.
You're welcome. Thank you all. Bye.